Hello, my name is Bala Garg. I'm a particle physicist and a postdoc at Stanford University, working with Atlas Collaboration at CERN. I'm also a member of IRIS-HEP since past 2 years. As a particle physicist, I have always been enthusiastic about the search for new physics and finding out ways to improve these searches. One such attempt of these improvements is our current R&D project, where we are exploring various machine learning-based parameter optimization approaches in order to develop an automatic parameter tuning algorithm for particle tracking in high-energy physics. Tracking the path of charged particles is one of the most complicated steps in the reconstruction of underlying physics processes. In this picture, it shows a random proton-proton collision events at LHC. And the red and blue dots represent the detected energy deposits, while the yellow line represents the particle tracks coming out of the collision. The tracking algorithm takes these energy deposits as input and reconstructs the particle tracks for us. Now, these tracking algorithms are mathematically complex structures with a large number of input parameters. These input parameters are highly dependent on the detector geometry and materials. Now, the performance of tracking is very much determined by these input parameters. Therefore, finding a right configuration for these parameters is very important. And we need to fine-tune these parameters as per the needs of a particular geometrical configuration. Historically, these parameters have always been hand-tuned based on some previous experiences, but finding a right configuration for these parameters is always been a challenge. Our current research is trying to tackle this challenge through the use of machine learning techniques. The testbed for our research is the open source tracking software known as ACTS. So in this current work, we are integrating ACTS tracking software with particle tuning algorithms. The tuning algorithm provides the set of input parameters to the tracking algorithm, which in turn computes a scoring function based on the tracking performance, and it provides the scoring function to the tuning algorithm. The tuning algorithm learns at each iteration by keeping a track of all the previous passes, and this way it tries to improve the input parameter configurations in an attempt to achieve higher scoring. And this way, with a large number of iterations, it is possible to achieve better configurations for the underlying tracking algorithm. Now, we are experimenting on a number of derivative-free parameter optimization approaches. Some of these include the distributed evolutionary algorithms in Python, Optuna hyperparameter optimization framework, scikit-optimize algorithm, and Lipschitz algorithm. Out of these, evolutionary algorithms uses genetic evolution-based selections and optimization to select different parameter configurations. Optuna uses tree-structured based Bayesian estimator kind of algorithm for selecting new parameter configurations. Scikit-optimize is a Python-based optimization algorithm integrated within the scikit-learn library, and it uses decision trees for making decisions on the parameter configurations. Lipschitz optimization is a parameter-free optimization framework, and it uses an upper bound on the scoring function to evaluate the various configurations. We have tested these algorithms on ACTS track finder in generic detector configuration. This figure here represents the tracking performance as a function of different angular detector regions. The solid black dots here represent the baseline performance with old parameters, while the other three colors represent the tracking performance with optimized parameter using different optimization algorithms. And we can see a clear improvement in the performance. Now, with the upgrade of LHC to the high luminosity LHC in the coming years, there will be large number of simultaneous proton-proton collisions, and the tracking environment will be much more complex. Therefore, in such kind of environment, these parameter tuning algorithms can be highly beneficial in providing a better parameter configuration as well as better tracking performance. Thank you.